Now, let's calculate the maximum reduction that is possible in a rolling process. For the same, we have made a schematic diagram here. The corresponding trigonometric entities are listed. Just give it a look and then come back to the derivation. Now here, the total horizontal force acting in the direction of motion of work would be given by F cos alpha minus N cos 90 minus alpha, that is equal to Rx. Now this Rx has to be greater than 0 always for the rolling process to occur. This N here is nothing but the normal force that we have previously taken as P, and this F is nothing but the frictional force. Now this F cos alpha minus N cos 90 minus alpha, which can be converted into sin alpha, would be greater than 0 because this is equals to the reaction force. In essence, we can say F cos alpha is greater than N sin alpha. Putting the value of frictional force here, we have mu N cos alpha greater than N sin alpha, or mu is greater than tan alpha. This particular equation, this particular relation, and this particular condition is required for the component to get pulled. Now let beta be the angle of friction, and hence under force of friction tan beta would be equals to mu, or tan beta would be greater than tan alpha. Angle of friction is greater than the angle of bite. Now for maximum possible reduction in thickness, cos alpha that we have already found out is equal to r minus del h by 2 by r. Solving it, finally we have del h is equal to twice of r minus r cos alpha. Now from this particular expression, as the value of alpha increasing, cos alpha will decrease, and hence del h, the maximum possible draft del h, will increase. So for maximum reduction, the angle of bite alpha should be equals to the angle of friction beta. Now when these two angles are equal, we will have tan alpha equals to tan beta. In essence, tan alpha would become equals to mu. Putting the values here, we get the maximum possible reduction as mu square r.